Well, hello everyone, and welcome back to Adrian's Digital Basement. I was recently doing a repair-a-thon here on the main channel of some Macintosh machines, and one of the computers, a Macintosh Classic, wasn't working correctly and I needed to replace a part on it, but I didn't have that part in stock. So I looked through all the things I had around the basement and I found this motherboard here, which was another motherboard from a Macintosh Classic, and I stole or borrowed the part off of this. Now, luckily the part was a Jelly Bean part that I can get from DigiKey, so I can go ahead and order that to get this motherboard up and running again. But I decided to take a different tactic with today's video. I was looking at the schematics of the Macintosh Classic motherboard, and it turns out that the Macintosh Classic motherboard really appears to be a Mac SE motherboard shrunk down. And one of the interesting things that's different about the Mac Classic versus the SE is that this thing only has 1 megabyte of memory on the motherboard, and to add up to 4 megabytes of RAM, which is the maximum that you can put on these types of Macintosh, you need to have a daughter card. A Mac SE, on the other hand, can actually accommodate 4 megabytes of RAM right on the motherboard. So in looking at the schematics of this board and the Mac SE, I think it's actually possible to relatively easily convert this to support 4 megabytes of memory right on the motherboard, and in the process I won't need the IC that I stole off here, and I can actually remove another one of the chips. So in this video, I want to try to take this memory module and get this installed onto this board and have 4 megabytes right on the main board of this computer with removing a couple parts and not even needing the daughter board. So without further ado, let's get right to it. Let's start off this video by saying that I think this modification that I'm going to try to do here is probably kind of pointless. I'll just get that out of the way and say that it's pointless. Most people are going to have that daughter card that plugs into this slot right here, and with that card you can just add two 1 megabyte memory modules along with the 1 megabyte that's on it already, and combined with the 1 megabyte on the motherboard should expand this thing all the way up to 4 megabytes. There are even replica versions of that daughter card now, and a new low-cost one that came out a couple years ago that should cost like $30 or $40. If you happen to be missing that daughter card, you need another one. The thing about the classic motherboard versus the Macintosh SE is that Apple made a few changes to this, just some minor things, to facilitate the capability of using this expansion card versus just having the memory in normal SIM sockets. And to do that, they've added a couple extra chips. One of them is this PAL chip here in the corner, which is a custom IC that you can't buy. And the other one is this 74LS174. That's the part I stole and put on the other motherboard. If you happen to have a Macintosh Classic motherboard that happens to have a damaged PAL chip here in the corner, then there's no way you can really get this thing working unless this modification, which I'm about to do, will actually get this computer up and running. I find these kinds of modifications kind of fun as well, because we're talking about a little bit of hardware hacking. Apple obviously designed this with 1 megabyte on here, and you were supposed to use this memory card to add the extra memory. I don't want to do that. I want to see if I can push the limits of this board and just get 4 megabytes installed right onto the motherboard. Now, when it comes to parts required to do this particular modification, that's of course if it actually works. We'll have to remove some stuff from the board, but then when it comes to new RAM chips, I'm just going to steal them right off one of these 72-pin 4 megabyte SIMs, which are relatively plentiful and pretty common and also very inexpensive. You might be noticing as well that this motherboard doesn't have any caps on it, so I'm definitely going to have to recap it before we can do anything. So I might as well do that right now. There it is. The board is all recapped. Unfortunately, one of the pads here had come off, so I had to do a little bit of bodge work to get that on. I also noticed that the left pad on this capacitor was no longer connected. I couldn't actually see that, but I did some continuity tests really quickly, and sure enough, it wasn't connected. So you'll see a little bit of extra solder on there, and that's because I ground away the solder resist. So when I flowed the solder on there, it made that connection again. I do have to mention that I recently put a video on the second channel on recapping one of these boards as well. So if you'd like to see the techniques I use to do it, start to finish, check that video out. I'll put a link in the description below for it. Okay, let's talk about the meat and potatoes of this video. You might be wondering, how exactly can I install 4 megabytes of RAM onto a motherboard that only has 1 megabyte of RAM? Because normally if you're thinking about SIMs like this, which are the ones that were used on the original Macintosh, each one of these is 1 megabyte, but generally you have to add 2 of these at a time because this is a 16-bit processor. Well, while these chips and the ones that are on the motherboard look relatively similar, they're actually not the same. Each one of these chips on these SIMs output 1 data bit each. So since there are 8 of them on one of these 30-pin modules, this is 8 bits wide. So for a 16-bit processor, you absolutely do need 2 of these installed at a time. Compare that to the chips that are on the motherboard here. This is actually 32 bits of RAM, meaning 2 of these chips actually is 8 bits, because each of these has 4 bits each. So 2 of these chips is 256 kilobytes, 8 bits wide, and 4 of them, of course, is 512K at a full 16-bit wide, and then when you add these all up together, you get a total of 1 megabyte. That is very similar to the construction style of one of these 72-pin modules, which are also 32 bits wide, and 2 of these chips is 8 bits, times 4, and you get 32 bits wide. So for a 32-bit system, like a 486 or a 68020 or 68030 computer, you could put one of these into your computer, and that's all you need to actually use it. Now, Apple, when they designed this, they could have installed a 72-pin socket, and then therefore it would have been easy to upgrade the RAM on this thing by simply taking that out and putting in a 4 megabyte module like this one. But I think at the time when they designed this, which was probably like 1989 or 1990, 72-pin SIMs weren't super common yet, and these came a little bit later. Now, what gave me the idea of upgrading this machine to a full 4 megabytes was looking at the pinout of these chips versus the ones that are on this motherboard. Essentially, the only difference between the chips that are on here and the ones that are on the motherboard is there is 1 extra address line on each one of these chips. I had mentioned this in my Mac repair-a-thon videos, that when you add 1 extra address line to a memory module like this, you actually take the capacity of the RAM and you multiply it by 4. Or if you take away an address line, you divide it by 4. The same even goes for these 30-pin memory modules. The sizes that you typically find these in are 256K, 1 megabyte, there are 4 meg versions, and then there are 16 megabyte versions. And that all happens because you're adding a single address line each time to increase the capacity. So my idea is that it should be pretty easy to remove these RAM chips from the board and take some off one of these SIMs and install them onto the motherboard, because all of the signaling should be completely compatible. And get this, the extra address line that's required for these larger capacity chips is actually wired up to these chips. It's just on these packages, that signal doesn't actually do anything. Now I have some data sheets pulled up for us to compare against so we can see the difference in the pinout between these 2 types of RAM chips. This is the RAM chip that's currently installed on the board, and it has address lines A0 through A8. This is the pinout of the larger chips that have the extra address line, and it's right there, pin 5, address line 9. But if you take a look at these 256 kilobit chips here, you'll notice here it says not connected. If we take a look at the schematics for the Macintosh Classic, and unfortunately we only have unofficial Bowmark schematics and not Apple branded schematics, this is one of the RAM chips on the board. And unfortunately the markings on this schematic are just not clear. In fact, it has pin numbers for all of these pins here, but if you notice up here, the address lines, they just left off the pin numbers altogether. And they were also super unclear because they wrote A0 through A9, and then there's a not connected right there, but that's actually wrong. It should be A0 through A8, and then there's that not connected pin that goes to address line 9, as we saw on the data sheets for the RAM chips. What we can infer from the schematics though is that address line 9 for the DRAM chips does actually make it to the chip itself. And even though it says NC there, it actually is wired up on the motherboard. The RAM address lines are all generated by this chip here, the Bob Bailey unit or BBU. And that's this large VLSI IC. And what this chip does is it takes all the discrete logic that was on the original Macintosh boards and combines it into this one large IC, which is why there's so few ICs on this entire motherboard. All right, so we have a path forward for taking these RAM chips off and upgrading them to 4 megabytes total by using chips salvaged from one of these memory modules. But what about the fact that I mentioned at the beginning of the video that we wouldn't even need the custom RAM PAL chip, which is this one here in the corner, or this TTL logic chip here that I took off in one of my repair-a-thon videos? Well, I personally didn't realize this, but when I was looking at the schematics, I started coming to the realization that this VLSI IC is the exact same one that is on the Macintosh SE. And on a Mac SE motherboard, it just has 4 discrete SIM sockets that support up to 4 megabytes right on the board. And while it's using these 30-pin memory modules, the truth is when you combine 4 of these together, you're actually the equivalent of having one of these 32-bit modules. Well, you might have noticed if you work with a lot of machines with 30-pin modules that later versions of these modules don't have 8 chips, but they only have 2 chips. And the way they made that happen is they use the same chips that are on here. You just take 2 of them, and then you would just basically have a cost-reduced SIM because you only have 2 chips, but you still have the 8 bits of data. So that really got me thinking. If that VLSI chip that handles all the memory stuff on the Mac SE is the same one that's on the Classic, then why couldn't we just install the equivalent of 4 of these 30-pin modules with 2 chips each, which is basically 8 of the chips from this module here, right on the motherboard, and just replicate the fact that there are not 4 SIM slots, but there's the equivalent of all the RAM chips from those 4 SIM slots just installed right on the motherboard. If you think about the memory that's on here right now, this is the equivalent of 4 of these 30-pin modules. If each module was only 256K, that would be a total of 1 megabyte. But what starts to get a bit more complicated with this board is when you plug in the module into this slot here and you don't have any 30-pin SIMs installed in it, what you're doing is you're adding an extra 1 megabyte to the Mac Classic. So you have a total of 2. And it does it in exactly the same way as the motherboard does it, using these 4-bit wide chips for a total of 1 megabyte. That's actually the equivalent of having 8 256K SIMs installed in the computer. And then what's possible is you can add 2 more 1 megabyte SIMs to that module, and there's a jumper installed on there, and it's able to address a total of the equivalent of 10 of these 30-pin memory modules. It all still works because you're always adding or removing memory in pairs or quadruples, which is just 2 pairs basically. But the thing is, all that extra complexity required them to add some additional logic on top of what the Macintosh SE has. And going back to the schematics for the Macintosh Classic, that extra logic is right here. It's this CAS PAL chip, and it's this 74LS174. Neither of these chips exist on the Macintosh SE, and that's just because they're not necessary. What these chips do is they generate additional CAS, or column address select lines, for all those extra memory modules that go onto the external card. The BBU chip on the Macintosh SE only has 4 CAS lines because there's 1 for each SIM, but since the Classic, with that memory board plugged in, has the equivalent of a bunch of extra SIMs, it needs to generate a bunch of extra CAS lines. So that's where I got the idea of just removing that CAS PAL chip entirely from the board, putting 4 megabytes of memory right onto the board, and then wiring up the BBU chip to the memory that's on the board, just like it would be done on the Macintosh SE, so that it just addressed all 4 megabytes on the motherboard without needing any of those extra logic chips. So after doing a bunch of studying between the Macintosh Classic and the Macintosh SE schematics and looking at the way the BBUs are wired into the memory on the Mac SE, I came up with a list of things I need to do to replicate the Macintosh SE design onto the Classic. So first off, remove UL1 and UH6. That's the CAS PAL chip, and that's this 74LS174. Luckily, the 174 is already gone from this board, so that's just one less chip to change. And then we have 2 things we're going to have to do for the BBU. Essentially, the BBU needs to be told that it has 4 megabytes right on the motherboard, and it needs to address all 4 megabytes directly by driving the CAS lines correctly. This is the equivalent on the Mac SE of setting that jumper or taking the jumper off basically that's on the motherboard that allows it to address all 4 megabytes. So we're going to have to remove a resistor on the back of the board, which currently pulls to ground, and we'll have to use a 10K pull up to 5 volts, which is what the BBU is going to be looking for. And then pin 17, I just need to verify that it's also already pulled up to 5 volts. I'm not 100% sure if pin 17 is pulled up to 5 volts. It looks like it is through 10K, but it also says also to SCSI pin 10. I'm not quite sure what's going on with that. So I'm going to just verify what's really going on there. Next up, we're going to install all of the RAM chips on the board. So I'm going to have to remove all of these old RAM chips, and then I'll install some new ones in place of those. And then in the empty footprint of where UL1 used to be, we're gonna have to bridge a couple things. So pin 6 goes to pin 24, and pin 7 goes to pin 25. That's just taking 2 of the CAS lines that are already coming from the BBU to that old PAL chip and passing them all the way through to the RAM. And then there are 2 additional signals on the BBU that we're gonna have to pick up. Pin 16 and pin 19, they currently don't go anywhere. I've validated it by looking at a PCB of a Mac Classic with that chip removed, and those 2 pins go nowhere. Those are the additional CAS lines we need that used to be generated by that PAL chip, but they're generated internal on the BBU, and we just need to route those through to the RAM. So we're gonna need to run those to UL1 pin 27 and pin 26. That's the same PAL chip that we've removed, so we'll need 2 bodge wires, and I will need to hook up a 22 ohm resistor in line with that. And that's actually it. So we have a total of 4 bodge wires, with 2 of them requiring to add a resistor as well. I'm gonna have to remove another resistor and then add a 10K pull-up, and that's probably gonna be another bodge wire. And then we have to just swap some chips. That's it. So there shouldn't be a lot of evidence of changes to the board, but then it should be running with 4 megabytes right on the board and never have a need to install anything into this slot whatsoever. So I think the first thing I want to do is, now that this board is all recapped, I want to actually plug this into the test bench here. I just want to see what this board actually does with that LS chip removed. So without making any other changes to this thing, Let's just see how operational or how functional this thing is right now. I predict it's probably not going to do anything at all. If anything, it might just crash immediately because I think the RAM is not going to be addressed properly to even show anything on the screen at all. So for testing, I'm going to be using this modified power supply here, which I used in the repair-a-thon video. Essentially what's happened to this thing is, well, A, it has a video output here to go to the RGB to HDMI, but then the other change is that I lifted a diode right here that disconnects the entire CRT side of this board. So essentially all this board is now is a power supply to drive the motherboard and an amplifier for the speaker. And I guess, you know, it handles the video output from the motherboard. But this entire section here with the flyback and stuff is all disabled. So there's no risk of 15,000 volts coming out of the flyback transformer right here. This thing is still super dangerous though, because this entire section of the board here is the no touch zone. This is the mains high voltage side. Everything else over here is low voltage and is actually, like, you know, safe to touch. Not that I'm going to be poking my fingers in there, but yeah, this whole area here is off limits for touching. The only other small tidbit about this modification is disabling the CRT section here actually raises the voltage on the 12 volt rail quite a bit because it shares a winding on the transformer here with this like 30 volt section here. So what I'm going to do is hook up this car light bulb to the 12 volt rail just so it actually loads down the 12 volt rail and it allows the 12 volt rail to be a much more reasonable 11.5 volts or something like that. And the 5 volt rail with this configuration ends up being just at 5 volts, which is perfect. I think we're all pretty much hooked up and ready to go. I have the video output connected to the RGB to HDMI. And I have to say, this motherboard was found in a random box of stuff, so I have no idea if it actually works. And it was in really bad shape before I took the caps off of it. So I don't know if it actually functions. So we'll see if it even does anything at this point. Okay. Wow. So it actually has a sign of life, even with that LS chip removed entirely from the board. That's pretty surprising. I would have assumed that it wouldn't have worked at all. So since we have an actual sign of life, I'm going to hold down Command-Option-XO to boot into the ROM disk file system. Oh, that's so funny. Did you see how it still showed what was there on the screen before when I turned it off? That's weird. How come that hadn't decayed yet? Anyhow, I'm going to boot up into the ROM disk by holding Command-Option-XO, and that's going to allow us to see how much memory is currently available on this thing. Oh, it's not working. Why not? The mouse works. Let's try that again. I seem to have trouble going into this diagnostic ROM disk sometimes. Very strange that it actually shows the image. There we go. Now it's booting up. How much memory are we going to have? I'm assuming we're going to have 512K, which is exactly the amount of memory that you get when that 74LS chip is just bad, which it was on the other motherboard that I repaired. So let's see, 512K? Yeah, 512K. Okay, so 512K for whatever reason just seems to be the default amount of memory when that 74LS 174 fails. That's an interesting test actually, because I didn't try powering up the Classic I repaired with that chip entirely removed. The chip I took off the board had only one output that was bad, but the rest of the outputs were actually working, but yet you still ended up with 512K just like this. Just a quick note while editing this video. I realize now why the system defaults to 512K when that 74LS chip is not working. It's because the configuration of the BBU, which is set by pin 13 and pin 17, is set up in such a way in the default configuration on the Classic to mimic the way the Macintosh SE would be configured for 256K sims. Pins 13 and 17 are normally connected to the jumper that's on a Macintosh SE, and when you have a Mac SE set for 256K sims and you only have 2 installed, you end up with 512K. Because the BBU's CAS1 low and high pins, which normally go to the other 2 sim sockets on the Mac SE, aren't connected to anything on the Mac Classic, those signals are actually generated by this UL1 CAS PAL chip. But since the 74LS174 is required to drive the CAS PAL chip, the CAS PAL chip obviously is just not really doing anything to generate those extra signals, and therefore the extra 512K RAM chips on the Mac Classic's motherboard are just simply not active, and therefore the system only sees the first 512K of RAM. I didn't realize this little tidbit while filming this video, but this is definitely what's happening here and why the system defaults to 512K as soon as that 74LS chip fails. So as you can see, I have the oscilloscope up, and the reason why is I want to take a look at a couple things. I am not 100% sure if the BBU or BBE chip or whatever this thing is called is actually the same between this and the Mac SE. It has a different part number, but it's weird because all of the signals on the in and out look identical. What I want to see is that if pin 16 and pin 19 actually have any activity on them. And that's because on this particular system, they're completely unused, and this CAS PAL chip over here generates those CAS signals instead. But for this mod to work and us to get all 4 megabytes of RAM, we're going to need these two signals to be, well, driving the RAM at least, because you can think of these CAS lines as the chip select lines for those particular SIMs. I went ahead and I just connected up a 3-volt lithium CR2032 to this machine, so that way I can power cycle it on and off. And I have it set to boot the ROM disk every time, so I don't have to do that like hand gymnastics to try to boot the ROM disk on this thing. So now if we power this machine off, power back on, strangely enough, it shows that, that old image, and then it boots right up off the ROM disk. Excellent. First thing I want to do is I am on pin 16 with the oscilloscope. If we power the computer off and on, are we going to see any activity on there? It is just pulled high currently. Now this is an active low signal, so only when it goes low is it actually driving the RAM. But we're not actually seeing any activity here, but that might be okay, because currently the BBU is not configured to actually drive all 4 megabytes of memory. That's because until I make the changes to pin 13 and pin 17 on the BBU is not thinking that this machine actually has 4 megabytes. It seems that CAS PAL chip is the one that's taking over the duties of configuring how much memory you have based on whether you have the card installed in the system or not. So first off, let's take a look at pin 13, and it should currently be pulled to ground by R42. And sure enough, it's just sitting right at ground, and I'm sure if I hit the reset button, yeah, nothing changes. It's pulled to ground through a resistor. And then the other signal that's relevant is this pin 17, which I already said should be pulled up to 5 volts, need to verify. So when I hit the reset button, I'm just wanting to make sure that it's not changing for some reason, since, well, I mean, it shouldn't change because it was pulled up on the schematic. It's just that whole SCSI thing it said on the schematic was throwing me for a loop a little bit. I just turned the computer off, turned it back on. No, okay, so that's good. So the only one we need to really fix is pin 13 on the BBU. I need to remove that resistor and put a 10K pull-up. I'm gonna do that mod first. I wanna see if we start seeing activity on those 2 lines on the BBU, this pin 16 and pin 19. We need to start seeing some activity on those to know this mod is gonna work. Otherwise, I think what we're gonna be stuck with is 2 megabytes of RAM, and we're never gonna get anything additional beyond that. Okay, so there's the resistor that I need to remove, and indeed it's a 470 ohm. So I'm just gonna pop that off really quick. Sometimes it can be kind of difficult to get these resistors off because Apple used glue. There we go, that came off. Since this board is wave soldered, they have to glue these components on the bottom side on, and then they run it through the soldering thing. And yeah, there's a little dot of glue under each one of these components that can make it a little bit harder to remove them. Now of this R42, there are 2 vias that these pads go to. One of them is ground and one of them goes to the BBU. Okay, the one on the left is ground and this one here obviously is the BBU. Okay, cool. And looking at the schematic, this R41 that's right next to it is a 10K resistor that also goes into the BBU. And it looks like on the left side of this is actually the 5 volts. That means I can actually just put a little tiny bodge wire from there over to the right side of that resistor, and we'll just share that 10K resistor for pull-up on both of those pins on the BBU. Okay, there's the littlest of bodge wires right there. That should be hopefully bringing both of those pins up to 5 volts. So I'll just do a quick verify on the other side. All right, if we go to pin 13 on the BBU, we should get 10K. We do, and I'm going to go to the 5 volt pin on the 74LS174, which is removed from the board. And there we go, we also get 10K. So perfect, okay, we pulled up that to 10K. Now, I forgot to mention at the beginning of this video that all the mods I'm gonna do to this board are 100% reversible. I'm not even cutting any traces on this thing. It's just simply bodge wires and removing and changing chips. That's it. Okay, with the bodge done, let's plug the power back in the motherboard and let's see if this thing boots at all anymore. Not 100% sure. No, it's not booting at all. Okay. Now what I want to see is when I turn this on, are we going to have any activity on pin 16 and pin 19 on the BBU? Yes, all right. And on pin 19, do we have activity as well? Yes, we do. Good. Those are the 2 CAS lines that we need to work, and they definitely weren't doing anything before I did that little bodge. All right, so now at this point, all the rest of the mods are on the top side of this board. And the next step is going to be to remove this CAS PAL chip and then create those bodge wires across it as I outlined in this document here. And I'm not going to change the RAM quite yet. I'm just going to leave the RAM as it is. Let's see if this thing can work even with just this 1 megabyte of memory. I think on a real Macintosh SE, if you have all of the 256K installed, but then you have the jumpers misconfigured for 4 megabytes, I think the actual computer still works. It just doesn't see all the memory. I'm not 100% sure though, so we'll just see what happens. And then if it still is not working, I will still go through and change all the RAM, and we'll hopefully have a 4 megabyte Macintosh Classic. All right, this is the chip that's coming off next. I'm going to use hot air and flux, and then I will use some of my solder braid here to clean up the pad so it looks all spick and span when everything is off. All right, there we go. So the bodges are complete, although I just realized I forgot to put those 22 ohm resistors in place. I think this is good enough for testing though. Those 22 ohm resistors are only there in case one of these goes short and just to protect this chip. So I'll definitely install those. But for right now, I think everything is good to go where we can at least test this thing with this 1 megabyte of RAM installed and see what happens. All right, everything is reconnected here. Let's see what happens when we turn this on. Okay. Okay, that is really good. So we're getting an image. That means that the memory is refreshing. So it's telling us that there's bad RAM, but I think it's because it's looking for 4 megabytes and, well, 4 megabytes of RAM is not on here. This is good. I know it's bad that it has an unhappy Mac, but it's actually good. Because remember, just making that one jumper change on the bottom of the board made this thing just do nothing at all. We had like a complete black screen. So this is a definite improvement. Now I need to go and remove all of those chips. And it's going to be exactly the same as removing this chip here. That's the CAS PAL chip. It's just going to be time consuming and lots of heat to get all of these RAM chips off one by one. All right, the deed is done. The soldering's kind of ugly because I'm really not good at surface mount stuff, but all of these chips have been switched over and I stole them off this particular memory module. What's cool is they're all Hitachi chips, which are the same exact type that I took off the board, except obviously these ones are higher capacity than these. I went through the multimeter and I validated that all of the connections that go through to all the chips, like say the address lines, make it through to all the chips, the voltage lines, stuff like that. I also went over and I checked every pair to make sure there were no shorts on any of these, and that checked out okay as well. And lastly, I double checked that the 4 CAS lines make it to the pairs of chips on here, and they all do as well. I took a look with the loop at the soldering that I did underneath these chips because I just used hot air to reattach these, and it's really quite ugly. There's not a whole lot of space in between these chips to get the tip if I want to kind of reflow those. So I'm just going to hope that all the connections for all the pins is actually okay. For now, I'm just going to put all of these old RAM chips over with my other parts here, the resistor and the PAL chip that I took off the board, because if I ever want to revert this back, I absolutely can. And I guess it's the moment of truth. Will this thing power up and at least give us the flashing question mark? I have the battery disconnected, so the PRAM is lost for booting off the ROM disk. Here we go, 3, 2, 1. Oh, oh, oh no! So close, so close. So obviously it was doing a RAM check here and it failed the RAM test, which is what this F3 is telling us here. Now let me just push down on all the chips here with my hand. Let's see if that makes any difference. No, same error. Okay. Now, how exactly do I fix this problem? On a normal Macintosh, if you had Sims in there, you would just take them out, swap them around, stuff like that. It's a little bit more difficult when the memory is on the board permanently here. I wonder if I could decode this error code so that we could try to figure out exactly like which data bit is bad here. One thing that's interesting is that the reset button actually does reset the machine. Before, when we had that immediate crash, the reset button and the interrupt button didn't do anything. I push the interrupt button right now. It doesn't really do anything. It just prolongs that there. Oh, and it causes it to reboot. Right. Well, I'm going to go do a little reading to see if I can figure out how to decode this. My assumption is that I did some bad solder joint on one of these. Even though I kind of went through and I checked everything, I have a feeling there's still some kind of a problem with the soldering. So I need to go investigate that a little bit further. Well, I did a little bit of reading, and oddly enough, the F error code indicates some kind of a software problem. So not a hardware issue at all. And a few people in the post I read suggested trying to boot the computer with Command, Option, Shift, and the backspace or delete key pushed down. And it like clears the PRAM, and that somehow could fix this. I suppose the fact is I had the battery connected and then I unplugged the battery for a while we did this soldering. So maybe somehow the information stored in the PRAM is corrupted, and trying to clear it might fix the situation. I'm skeptical, but let's give that a try. Okay, I have all the keys pushed down. It's a little bit difficult because I can't stretch across the entire keyboard, so I'm resting this blue thing here on top of the delete key. Let's turn this on, see what happens. I'm skeptical this will do anything. Well, the code is different. Now it says A instead of, I don't know, 3, I think it said before. And now it says 3 again. This is interesting, very interesting. And now we have a 2 error code. So it does seem to be just kind of randomly changing. So I've been poking around on the motherboard with the oscilloscope, not really finding anything interesting. And I'm curious if maybe I have a couple of the column address select lines hooked up backwards. Here's a schematic I found for the Macintosh SE, and this is what I really based a lot of this stuff off of. And if we take a look at here, here's the gate array or the BBE or BBU or whatever it's called. And here are the column address select line outputs. So there are 2 for high and 2 for low. The 2 lines that weren't connected at all on the Mac Classic were pins 16 and 19. So those are the baud wires that I ran from the BBE over to that PAL chip I removed to connect it to the RAM chips. The 2 that were actually connected through were pins 15 and 18, this low line and the high line, which, according to my little notes here, pin 15 CAS 0 low should make its way to pin 7 on UL1, and then it goes towards the RAM chips on pin 25. So that is pin 15 CAS 0 low, which is right here, and it makes its way over here to pin 7, which does match what I have here, pin 7 CAS low, and I have that going to pin 25 here, which makes its way to chip number 5 and 7, which you can see on this schematic are data bits 0 through 7. So I think I just need to double check and tone out these pins, pin 17, on these RAM chips, UK5 and 7, and make sure they make their way all the way back to pin 15 here on the BBU. All right, so this pin here needs to go to pin 15 on here. All right. This doesn't seem to be connected all the way through, and I'm on UK7 there. Yeah, the multimeter's a bit hard to see, but I think I have these swapped. It's on the other pin. There it is, 22 ohms. Okay. Incidentally, looking at this Beaumark schematics, we have yet another error. It says the CAS lines go to pin 17 on the RAM chips. That's totally wrong. It goes to pin 23 on the RAM chips, not pin 17. So yeah, there's quite a few things on this schematic that you have to take with a grain of salt. So what I'm going to do is swap those 2 column address select lines around. Now, incidentally, you might be wondering, why does the video work? Well, the video is working because the video and the sound buffer always exist at the very top of the memory space, and the BBU on this is configured for 4 megs of RAM. And those 2 extra baud wires I connected from the BBU itself all the way around to that IC that I removed, those were the CAS 1 high and low lines. Well, those are obviously connected correctly to the RAM. So it does appear that this thing is seeing the 4 megas of memory properly, and it is able to write into that upper memory. But I guess what's happening is down below, the column address select lines are reversed. So when it tries to write to that lower memory during the RAM test, I think it might be failing because it's turning on the RAM at the wrong time. Now, I might be totally off base here, and we might swap these around and there's going to be no change, or it's going to be worse, but it's worth a try because it does seem like, at least from the logic that I've worked out, that I did hook it up backwards. You know what? I just disconnected those two column address select lines, the CAS 0, low and high, so they're not even connected at all now. Let's just see what happens when we turn on the computer, what it does. Okay, it immediately gives us a sad Mac. And I can't read the number, but yeah, so it's super duper unhappy now. All right, I think those lines are swapped. Let's see what happens now. Oh, 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 it would have crashed by now. And remember, with 4 megs of RAM, the Classic takes quite a while to check the memory, which is this slashed pattern we're seeing here. Maybe not this long, though. Oh, oh, I think it's done. I think we have it. Yes, the world's first 4 megabyte Mac Classic. Oh, this is amazing. Okay. All right. This is so cool. Well, let's go right for the blue SCSI here. And let's boot this thing right up off SCSI, and we'll just skip over that silly ROM disk entirely. All right, here we go, everyone. Here we go. Okay. This is so cool. It is amazing when a plan comes together. It really is. Oh, it's so cool. It is. I mean, I'm sure this has 4 megs. It took a long time to do that initial RAM check. It's booting the system here. Oh, yeah. Oh, yeah. Let's see. 4 megabytes. World's first. I mean, that I know of. I couldn't find anyone else talking about this. Boom. A Mac Classic in 4 megabyte mode, no expansion card needed, and I removed this extra PAL chip. So if this chip goes bad, your Classic is actually usable. You don't have to throw it away or turn it into a parts board, because there we go, it freaking works. Now I'm trying to think about why someone would want to do this mod. I talked about this at the beginning, you know, it's sort of a pointless mod, but there are a couple good reasons why you might do it. One is the little PAL chip that's on here, this chip here, well, this can get damaged, and Apple never released the equations that go in this, so there's no way to replace that unless you're taking it off another board. I mean, maybe someone could reverse engineer it, but who knows if anyone has done that amount of work. The other thing that's kind of cool is, what if you're trying to make a little pizza box Mac that's really, really compact and small? This thing, without that RAM card sticking out of it, means that you could put a little Pico ATX power supply and have a little tiny 68,000 Mac that's literally only this big as this motherboard, and you just need to kind of stick the little power supply off to the side, and it should work. So that's pretty cool as well. But I think the reason why I did it is I love this hardware hacking thing. And I love the fact that this Classic really is like a Macintosh SE. And the VLSI chip on there, the BBU, is really just the same one that's on the Mac SE. Has a totally different part number, but yet it clearly functions as if this is a Mac SE. I have no trouble believing that if we took Mac SE ROMs and put it into a 16-bit ROM chip that would fit onto this board, that it would completely and utterly work as a Mac SE. There's no functional difference between this computer and a Mac SE whatsoever. The real only difference between the Classic and the SE is that the brightness control on the Classic is software controlled. But the weird thing is the BBU chip, the VLSI chip, is what controls that output. It has a PWM output. Well, the Mac SE has that same pin, and it's also a PWM output. Looking at the Mac SE schematics, I can't figure out where that line even goes, but that pin is labeled PWM, and, well, who knows what it's doing? I don't think anything. My only thought is when Apple designed the Macintosh SE and that chip that goes on it, the VLSI chip, they probably wanted to give it software-controlled brightness control right from the very beginning. But maybe they didn't want to change the analog board, or whatever reason, they just left that part unused. And when they took that chip and put it onto the Classic here, they actually implemented that in the ROMs and also the analog board, so it's working together to control the brightness. But I do think it's pretty amazing that I basically revived the Macintosh SE functionality that's in that VLSI chip to drive all 4 megabytes directly on the motherboard, and I just got rid of those additions that Apple added for the Macintosh Classic. And it is funny, actually, that looking around on the forum posts, people were saying that that sad Mac code that was coming up was due to a software error. Which is clearly not right. So it's pretty funny that there is not a lot of information when it comes to decoding those sad Mac error codes. If you have any desire to do this particular mod to your Mac Classic, or perhaps it's sometime in the future and someone is trying to repair a machine and they want to follow these instructions, I will put them in the description below. I'll make sure to flip around those 2 CAS lines in my notepad file before I paste it there, since my little ROM decoding was wrong. Although I think I did it right. The Bowmark schematics are actually wrong on the way that the Classic is actually wired up. But anyways, there's all sorts of errors in there. But I said this in my Mac repair-a-thon. Having some schematics is so much better than having no schematics, because I think without them, I wouldn't have even been able to attempt this particular mod. Now I'm just running the speedometer test suite here just to make sure the machine is performing as it should, and it is absolutely performing perfectly. CPU 1.0, graphics is 1.0, a Mac Classic is the reference for this particular app there, so it should score a 1.0. Obviously the disk, that part's going to be a little bit different because I'm running on Blue SCSI, and that original test was probably on whatever original SCSI hard drive was in here. But we know that this particular mod with this 4 megs of RAM on the motherboard just results in, well, exactly the same performance, which completely makes sense. It would be highly, highly unusual if the computer were somehow running slower than it would normally. Yep, there we go. Everything is running exactly at 1.0. So there we go. I'm going to end this video here. It was a blast to actually do this. I love this kind of hardware hacking where I have an idea about something that might work, and sure enough, it works, especially when it's something that potentially no one has ever done before. So I think that's extra cool as well. If you like this video, I'd appreciate a thumbs up, but if you're not, you know what to do. Hit that subscribe, all the usual YouTube junk, and a huge thanks to my patrons. Their names are scrolling up the side of the screen. My patrons make it possible that I do this full time, so huge thanks to them. If you want to become a supporter, you can do so, the link in the description below. You get early access to videos and, you know, stuff like that. And I guess that's going to be that. So stay healthy, stay safe, and I will see you next time. Bye-bye.